So these are the answers to the Chapter 4 review. Chapter 4 looks at congruence of triangles. So we start with number 1. It asks us which type of triangle has an angle measure greater than 90 degrees. So this is identifying triangles by their angles. And if we think of greater than 90 degrees, we're thinking of an obtuse angle, and an obtuse angle will be greater than 90. So number 1 is C, obtuse. Number 2, given that AD and BC intersect at X, and we have AX is equal to BX, CX is equal to DX, which theorem justifies that our triangles are congruent? Now we also have another piece of information we need here, because we do need 3 things. Let's move these down a little bit. Since they intersect at X, we actually have vertical angles. So by that, we can see that it's going to be side, angle, side, or answer C. For number 3, we need to find angle Y. Now, let's redraw that a little better over here. This is the part we need. So I have 60 degrees, I have 40 degrees, and I have Y. Now I can do the vertical angle to 40 and put it inside the triangle. If I did that, then I could find the missing angle in the triangle, which would happen to be 80 degrees, because it has to add up to 180, and then subtract that from 180 to find Y, which is 100. Now, what you could also approach this problem as is thinking of an exterior angle. The exterior angle theorem told us that the exterior angle is equal to the sum of the measures of the non-adjacent interior angles, or the ones not next to it that are inside. In that case, it would be 40 and 60, which would also add to 100. In either case, though, if we went with the longer version of just plugging in, working our way through with the triangle sum, we again get to 100 degrees, which is D. Number 4, what type of triangle has 2 angles that measure 30 degrees? That sounds like a good one we can draw. 2 angles that measure 30 degrees. Well, let's see. If I have 30 and 30, I need another angle. Those add up to 60. If I subtract that from 180, I have 120 left. Well, if I have an angle that's 120 degrees, like we talked about in number 1, that's greater than 90. It's going to be obtuse, so our answer is B. Number 5, we need to find the measure of angle X. Now what I like to do on that, when I need to find the angles, I look at its corresponding letter. X corresponds to E, so whatever X is, that's what E is going to be. And I can use that to help me, because in the triangle EFG, I know that angle G is 90, angle F is 60, that combines to be 150, which leads 30 degrees for angle E. So I'm going to say my answer for angle X is 30 degrees, which is D. Number 6, which postulate or theorem would we use to show the triangles are congruent? Well, I have 2 sets of angles so far. I need another piece of information. And since line LK is in both triangles, it is reflexive, so we can say that is congruent. That gives us angle, side, angle, because the side is between the 2 angles, so our answer is A. Number 7, the angle formed by 2 legs of the isosceles triangle is called the what? Now our legs are considered our congruent sides. We know that the angles opposite those sides are called the base angles. The angle on the top is actually called the vertex angle. So that's a vocabulary term for us, so our answer will be A. Last one on this page, which of the following statements is true? Okay, an obtuse triangle has 1 obtuse angle. An obtuse triangle has 3 obtuse angles. An obtuse triangle can also be equilateral, and a scalene has 2 congruent sides. So what's good here, is good practice, is to figure out why the wrong answers don't work. We'll start with D. A scalene triangle. A scalene triangle means it has no congruent sides. If it has no congruent sides, then it's certainly not going to have 2. So that's out. An obtuse triangle can be equilateral. Well, for it to be equilateral, it also has to be equiangular. Now, an equiangular triangle is going to have all angles 60 degrees. Therefore, it's not going to have any obtuse angles, so that's out. An obtuse triangle has 3 obtuse angles. Now, an obtuse angle is greater than 90 degrees. But we know a triangle has to add up to 180 degrees. So if I have 3 angles that are at least greater than 90 degrees, that means the total of those angles will be greater than actually 270, which is far more than 180. So our answer is A. An obtuse triangle has an obtuse angle. If you're not sure about that, if you're still trying to work through one just like that, try drawing them and see if it works out and see if you can fit it to its definition. Now we're on the second page, number 9, and we will find which statement is true. So let's start off and try to see if we can start sketching these out. If 2 sides in an angle of one triangle are congruent to 2 sides in an angle of a second triangle, then the 2 triangles are congruent. Now we have to be careful with that one because we could be talking about side angle side or angle side side, which does not work. It doesn't indicate where that angle is. Now we go look at number B, or letter B, and it says 2 sides in the included angle are congruent to 2 sides in the included angle of the second. That's referencing side angle side. That one would actually work. So we're going to consider that answer. C says if 3 angles of one triangle are congruent to 3 angles of a second triangle. That would be angle, angle, angle. And we don't have one of those. We always need at least one side. So that one's out. And then last one, D, a right triangle is isosceles. Well, I can draw an example of a right triangle that is not isosceles. So therefore, that means that is not always true. It could be. You could have a right triangle that is isosceles, but it's not always true, so we're not going to use it. So our answer for 9 will be B. Number 10. Which of the following sets of information does not allow you to conclude that ABC is congruent to DEF? So let's draw 2 triangles. So I have A, B, C, D, E, F. Alright, so we go AB is congruent to BC, or AB is congruent to DE, BC is congruent to EF, AC is congruent to DF. That looks like side, 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 so that one looks like it would work for us. Okay, so that one looks good. Let's get rid of some of these. Okay, next we go angle A is congruent to angle D, angle B is congruent to angle E, angle C is congruent to angle F. Well, wait a minute. We don't have any sides. I can see that from the beginning. I don't have any sides. So that would actually be angle, angle, angle. But that poses a problem because angle, angle, angle isn't allowed. Now, let's finish up the rest and check. AB congruent to DE, BC congruent to EF, and then B is congruent to E. That looks to me like side, angle, side. So we'll keep that one. And we have our last one, AB congruent to DE, BC congruent to EF, and then that A and D are right angles. Now, we look at it, at first looks like angle side side, but since they're right angles, it's actually hypotenuse legs. So which one does not work? It's still going to be B. We cannot have angle, angle, angle. Okay, number 11, which one would you use for our 2 triangles here? I see 2 angles, 2 sets of angles, and the side is not between them, so that would be angle, angle, side, so that would be C. Number 12, which one would we use for our diagram given? Well, I have reflexive, so I'm going to mark that, and I see that I have an angle and 2 sets of sides. Those angles are between the two sets of sides, so that would be side, angle, side. So our answer would be C. 13. If I have a 90 and a 45, I can find the other angle in that triangle, and it turns out it's actually 45. So when I need to solve for x here, it turns out I have an isosceles triangle that 3x plus 4 and 7x minus 8 are equal, because again, it is isosceles. So I set them equal. Let's add 8 to both sides. I get 7x equals 3x plus 12. I subtract 3x from both sides. 4x equals 12, and x equals 3. But they want the length of the leg, so I need to plug that back in. Let's do 7 times 3 minus 8. Gives us 21 minus 8, or 13. So 13 we had was D. And be careful there, answer the question. It would be really tempting just to write A and stop because you got 3, but the question was the length of the leg. Alright, number 14, classify the triangle at the right by its angles. So it's going to be one of those 4. We don't know yet, but we have to solve with them. So I'm going to do 4x plus 10 plus 3x plus 10 plus x equals 180, because the angles in a triangle have to add to 180. I combine those and I get 8x plus 20 equals 180. 8x equals 160, so x is 20 degrees. I go in and plug that in, I get 20 for x. 3x plus 10 is going to be 3 times 20, which is 60, plus 10 is 70. 4x plus 10 is 80 plus 10, or 90. I can see the angles do add to 180, so that's a good check to have, but it is going to be a right triangle because I have a right angle. So that would be answer D for 14. 15, find the value of x. I have an isosceles triangle, so that means these two angles are the same. If I subtract 110 from 180, I get 70. That's how much is left for each of those angles, but since they're equal, they're both 35, so our value of x is D. Last page here, we're going to start with 16. After translating our point 4 units to the right, what are the new coordinates? And if we think 4 units to the right, we add 4 to the x direction. So we're looking at something where we add 4 to x. C looks like the best choice. Y did not change, we only moved horizontally. 17, we have a transformation where we shifted. If I look at J, it moved to a new point. H moved to a new point. G moved to a new point. So what I want to do is count to see how much each of them moved. Well, H moved 8 units down. J moved 8 units down, and G moved 8 units down. So it's not a reflection because everything shifted the same amount. It's like it slid down the paper. It's going to be a translation where if we move down 8, we're looking for something that has y minus 8, so that would be answer D. Oh, falling behind. We got 16 was C, 17 is D. Okay, 18. We have a needle on a compass. It's rotated clockwise 180 degrees. We need its new coordinates. So for this one, we want to rotate around. Now, if I go 180 degrees, I essentially form a straight angle. I went over 3, up 4. To make that straight line, I'm going to go left 3, down 4, and it gives me my new point at -3, -4. So my answer would be D. And whenever you rotate 180 degrees, you're essentially changing the signs of the x and y value. Kind of a shortcut we have. So now we have a polygon, which is a mapping, and what translation moves to point A to 0, 0. So I'm at -4, -2. I want to go right 4, up to, right 4 would be 4 to the x, positive. Up to would be 2 to the y value. So I'm looking for something similar to that. I'm going to take answer A for 19. Let's finish up here with some angle problems. I have exterior angle is 2x, and that is equal to the sum of the non-adjacent interior angles. So I could say 2x equals 50, so x is 25. You could have also found that 50 was 30 plus 20, and that this angle would have been, in here, would have been 130. Subtract that from 180, divide by 2, you'd still get to the same answer. 21, since they're all inside, I say 2x plus 5 plus 8x plus 25 equals 180. That becomes 10x plus 30 equals 180. 10x equals 150, so x is 15. And the last one here, I have the exterior angle. Exterior angle is 5x plus 40. Well, let's use that to help us, like we did 2 problems ago. If the 50 is the angle here, and I have isosceles triangles, 50 from 180 is 130, so each of these angles are 65. So that means my exterior is equal to the 2 interior non-adjacent angles, which is 50 plus 65. I get 5x plus 40 equals 115. 5x equals 75, so x is 15 degrees. Now, got a little bit ahead of ourselves. We need to make sure we identify these triangles by their angles. Almost forgot. If we go back to number 20, we said that this angle was 130, so we have obtuse. Looking at our second one, 8 times 15 is 120. And this would give us 35 for 2x plus 5, also obtuse. And the last one, not only is it isosceles, but we have all angles less than 90 degrees, so it would be acute. Last 2 problems, now we're finding the value of x and naming it by its sides. Since it is isosceles, I can say that 54 equals 9x because those are the congruent sides, so x is 6. And again, it's isosceles. And then for 24, all the sides are the same, so it is equilateral. And if it's equilateral, it's equiangular. And if it's equiangular, each angle is 60 degrees, so 5x equals 60 gives us x equals 12.